So this question is looking at the gravitational field strength, and it's one of these questions where you're given different ratios and about proportionalities where it's changing. Now we've got a radius half the Earth's radius, and immediately you might start thinking, okay, so if it's half the radius, the volume is 1/8 of the volume, therefore the mass will be an eighth, and all these things if the density is constant. But if you read the whole question, we are told quite clearly that the mass is a quarter of the Earth's mass. So gravitational field strength is equal to gm over r squared, and therefore g is proportional to the mass. So if I half the mass, so a quarter of the mass, then the gravitational field strength is 1/4. So I've got a factor of a quarter here due to the change in mass. But the radius is half, therefore if the radius is half and g is proportional to the inverse proportional to the square of the radius, then if I half that, then that is a quarter, but it's 1/4, so it's 4 times bigger. So because the radius is 1/2 of the original radius, that means that you are twice as close, but it's a square relationship, so it's 4 times as strong because of that increase in proximity, so that reduction in separation. So the mass is a quarter, the radius is a half, so we end up with these two actually cancelling out, so we're back to the same sort of gravitational field strength that we'd expect with planet Earth.